வாட்ஸ்அப் hear my voice, students? Are you hearing?
Now I can hear your voice, sir.
Okay. Okay. Yeah. We discuss about the structure of the simple inorganic molecule, right? Today we'll see how the molecule is the stimulation. See, when you are taking water molecules, okay, if you see the electron geometry, it become tetrahedral. So look here, this will be like this. So you see now, two white atoms is there, no? This will be oxygen. This will be oxygen. The red color will be nitrogen. So the two lone pair will be is there, no? So when you have this two will be in the same plane, other two will be in the towards you. So look now that this one is towards you. The white one is backside you. But these two are the same thing. You can take the SF molecule. So last time we discussed the SF4 molecule. What is the structure of SF4 molecule? Seesaw. So look here. When you are having the molecule, it becomes trigonal bipyramidal. Look at electron geometry is trigonal bipyramidal. When you molecular geometry is seesaw. So overall, without leaving your lone pair of electron, it's seesaw. Now you bend it. It becomes like seesaw, no? Seesaw, right? Am I right or not? Okay. So now look here. So when you are changing, it's a trigonal bipyramidal. Okay. Become easier, no? So, what's your name? Srividya. Srinidhi. So the molecular geometry is seesaw, right? With the electron pair, if you are considering, it's a trigonal bipyramidal. It's like this. Okay. So when you take models, it is model. Real molecule, really existing molecule. That's why we have chosen SF4. Okay, you can choose any molecule like methane. See, this is the tetrahedral. If your model, that blue color will be the center of the atom, and two will be there. No, you could see, right? So this will be the tetrahedral shape. And then you choose any molecule, you choose XCF2. Okay, it's a linear, but generally it has trigonal bipyramidal. We'll calculate for that. XCF2, no. So will you do for XCF2? XCF2. You tell me how to calculate total electron pairs equal to what is the central atom here? Look here. Xenon. Xenon coming under inert gas, right? So 8. And get last one is 8. No change. Then 2 atoms are attached. Plus 2 by 2. So 8 plus 10, 8 plus 2, 10, 10 by 2, 5 electron pairs. So among the 5 electron pairs means, what is the structure? Trigonal bipyramidal. There is no doubt about it, right? You check it. When you have 5 means, what you are getting the structure? Here, here. Here are 5 means, what is the structure? Trigonal bipyramidal. Okay. So you should have trigonal bipyramidal, but you have only 2 atoms. So you have to calculate lone pairs. How to calculate lone pairs? Total electron pair minus number of attached atoms. So 2 atoms are attached. So 3 electron pair. So totally 5 electron pair. Among the 5 electron pair, 2 are bond pair, 3 are lone pair. So when you have the shape like this, this is the trigonal bipyramidal shape, right? Am I right? Trigonal bipyramidal shape. Now you have 3 lone pairs. You know that lone pairs will occupy more space than the bond pairs. So when the 3 lone pairs are here means it will be 120 angle. 2 lone pairs are in the lone axial position and 1 will be equal to it means 120 and 90 will be there. That's why 3 lone pair will occupy the equatorial position. The remaining 2 bond pair will occupy the axial position. Now you look this. That's why the shape become like this. Okay. So, are able to understand? Cyanide difluoride. So now I will tell you how to simply calculate this one without using this formula. Okay. So what is the valence electron of the central atom? You put 8x 1, 2, 3, 4, 5, 6, 7, and 8. Right? So you have to remember halogen will be attached singly. Single. Okay, single bond. And then oxygen double. Nitrogen. You remember these 3. Triple. Okay. So now this is the total electron of xenon. If it is plus, you have to subtract 1. If it is minus, how many minus is there? That much you have to add. Okay. Now you have xenon. How many fluorine attached? 2 fluorine. 1, 2. Remaining 1, 2, 3, 4, 5, 6. You pair it. 1 pair, 2 pair, 3 pair. That's all. Now you got that lone pair and bond pair now. Same way, you tell me one molecule. You tell one molecule, you tell one molecule. PCl. You tell me one molecule. CF. CF. C. CF. CF. CFL. 5 of. Else. No, the molecule is not exist. Carbon valence only you have 4. Huh? HCl, it's a very simple molecule, no? You have to take polyatomic molecule. You should not take diatomic molecule. Diatomic molecule maximum it will become a linear. Okay, you have to take polyatomic. Polyatomic 2, 3. Like that you have to take. Then tell me. Huh? H2. Okay. Okay. First you tell me what is which is the central atom here? What is that valence electron? It's coming under nitrogen family. Then how much? 5. 1, 2, 3, 4, 5. How many chlorine atom is there? 5 chlorine atom. 1, 2, 3, 4, 5. So 5 bond pair. Okay. All are bond pair. No lone pair. 5 means what is the shape? That's all. Trigonal bipyramidal. And then 5 electron pairs. No. For the hybridization also we can say S, P, D, F. Like that only. S means you have 1. P means you have 3. Then only you have to go. Totally how many is there? 5. 1 plus 3, 4. Then remaining what is there? D. So the hybridization may be sp3d. Okay. Now we'll go for the water molecule. So which is the central atom, man? Which is the lowest number, that will be the central atom. More number, it's not central atom. 1, 2, 3. Oxygen become 6. Balance atom. 3, 4, 5, 6. How many hydrogen atom attached? 1, 2. Remaining will be 1, 2. So 2 bond pair plus 2 lone pair. So totally 4 electron pairs, right? 4 electron pairs. What is the shape? it become tetrahedral, correct? It become tetrahedral. But our BAC pair theory told that lone pair interaction will be more than the lone pair bond pair. So what happened? It become shrinked. So oxygen will become like this. And then totally how many is there? 4. So if you take 1s and 3p, so it will be sp3. And then you tell another molecule. சும்மா நீங்களே பாருங்க, இந்த புக்ல பார்த்து கூட சொல்லுங்க. Those who are in the online, you can also say some molecules, ma. Simple molecule, beryllium dichloride, BC. Huh? Correct. Beryllium. So beryllium belongs to S block element. Okay. So it has only 2 electron, 1, 2. Okay. It will bond with 1 chlorine and 2 chlorine. So 2 bond pairs. Only 2 bond pairs. 2 means 1s and 1p. So it becomes sp hybridization. The shape will become linear. That's all. Simply. So you can find out the hybridization as well as the shapes. Okay. Now we'll go to the stimulation. First PCl5 getting on. So when it become like this means you can see. That's why they are given. Axial will become in this position only. So these two only oxygen. Okay. So this is the shape of molecules. You can rotate. If you want, you can rotate. Rotate, you can see. Okay. So how the molecules you have to view trigonal bipyramidal means simply you give that. That axial portion will become like this, and the equatorial portion, these three will become 1, 2, 3. That is the point. Okay, see no? The linear one is top and bottom. One become this side, another one become this side, another one become this side. That's it. Okay. PCl5. Okay. Trigonal bipyramidal, because no electron. You take water molecule. So 2 lone pairs. Okay. Look here. When the atoms are combined, that means see the space. Whereas the lone pair, how much space it will accommodate? Because the electrons are present in the single atom. So the electrons are present between the atom. Here bond pairs between these atoms, right? These 2 atoms. Whereas the lone pairs will be on the oxygen atom. The lone pairs on the oxygen atom. So you look, the red is the water molecule, so oxygen atom. White is 2 hydrogen atom. So if you are looking, the shape become bent. Okay, you leave. So without electron geometry, you can see only V shape, no? So it may be bent or V shape. If you are looking that with the electron geometry means it become tetrahedral. Molecular shape means bent is enough. Okay. Geometry means you can take with the electron means electron geometry. Whereas shapes, that is molecular shapes. Okay, so bond angle also it become 1 or so this is the bond angle, the distance between these 2 atoms. So that is bond angle. When you are having bond angle means here you cannot calculate the bond angle, right? If the rotating wherever it is, it will become 104.5. Okay. Next, so what molecule you have told? Methane. 109.5 or 108.230. You can say, methane, ammonia. Become, why it become 107 due to presence of 1 lone pair. Are able to understand structures? So if you have SF6, so that is a tetrahedron. Look here, the four atom in the square. One will be the above, another one will be the below. So all become 90 degree. So octahedral geometry. You told XCF to know. So look here. Okay, 3 lone pairs in the 120 degree, but the bond angle is 180 degree. This one and this one. How much it was separated? So it shows the plane. No? Yeah, if you want, you can also rotate. Rotation. Nothing. Molecules in the 3 dimension. What they showed, no? Molecules in the 3 dimension. If you want to see, you can connect the pens like this square, and one will be the above, another one will be below. Why it is octahedral? 1 space, second, third, fourth. 4 space at the bottom. Same way, 5, 6, 7, 8. 8 space at the bottom. That's why we are saying it is a octahedral. Tetrahedral means when these two, one more pen. So look here. You have one B, okay, one B like this. Another B become one will be the towards the another one. So when you are connecting these 3, this will be the shapes of tetrahedral. Why it is tetrahedral? 1 space, second phase, third, and bottom of 4th. So you can see, so that 2 V's are there, 1 V in the same plane, 1 and 2. This will be towards you, away from you. Towards you, away from you. Or otherwise, if you are taking these two in the same plane. This is towards you, this is away from you. Whatever the solid line showing, no, that shows this one. Whatever dash line shows, no, it shows this one. This is how we have to visualize the molecule. Why we are taking this molecule? Why we are taking this molecule? When you are going and finding the molecules, okay, how the structure will become. Okay, what is tetrahedral? What is octahedral? You should know the structures. So in the lattice, how it will be fitted below. But if it is octahedral, this is octahedral. This is the tetrahedral. This is the trigonal bipyramidal. So in the 3 dimension, in the space, how the atoms are oriented in the molecule. That's what we are getting from the BAC. So this theory clearly gives an idea without equal any mathematical relation. We are doing any calculation. What is this orbital? Where present? What is the energy of orbital? Nothing we are doing. We are simply taking the balance energy and how many atoms it is attached. Okay, so they are calculating total electron pair, lone pair, and bond pair. So the electron pair which decides the molecular charge. Okay, so we are taken simple molecule to complicated for the polyatomic molecule. Here no BAC 3. That day we have drawn up to 5. Only 5. So we'll go for the BAC theory. Up to 5 we have got now. So 5 means 5. So 4 plus 1 also we draw. So this is bond pair, this is lone pair, 3 bond pair and 2 lone pairs. Which we draw for 5. Okay. If it is 3 means this is the central atom. 1, 2, 3. Okay, attached atom. The 2 lone pairs will be present on the axial position. So AB3, E2. That E2 is nothing but lone pairs. So it has the angle of 120 degree. Suppose 2 bond pair, 3 lone pair. what will be the structure? What will be the structure? AB to E3, huh? Very good. Linear. B. Is it clear? So now we have to go for the sixth one. Six means what? So six bond pair only. Okay, no lone pair. So AB six. So when you are drawing the molecule A, so A is the center. 1, 2, 3, 4. B, B. So what is the shape? This. So I will draw first. How the octahedral. This is the center. Okay. Center of the atom. A atom. Okay. In this A, with six atom. 1, 2, 3, 4. So what I can do for two colors I can do 4, 5, and 6. Okay. Atom 1 B. Okay. B வேற கலர் கொடுத்துடலாமா? B's, 1, 2, 3, 4, 5, and 6. Okay. When you connect using B, we can connect 1, 2, 3, 4. The red I can connect 1, 2, 3, 4. So now one front to back, this side, this side. Okay. So and then we connect the bottom 1, 2, 3, and 4. That's all. Okay. This is what here it was shown. You could see it. Okay. So you have to connect all this, then you will get the perfect answer. Is it clear? Okay. Now suppose if you have 5 bond pair and 1 lone pair, A, B, 5 and E, what will be the shape? You tell me. So இங்க பாருங்க, அக்டாஹெட்ரலுக்கு ஒரு ஸ்கொயர் வரைஞ்சிடுறீங்க. ஓகேவா? அந்த ஸ்கொயர்ல இருந்து ஒரு பிரமிட். இது மேல. அதே போல கீழே ஒரு பிரமிட். 2, 3, 4. சரி, எனக்கு போட வரல அப்படின்னு சொன்னா அக்டாஹெட்ரல்ல சிம்பிளா யூ டிரா எ ஸ்டார். இது வரைய தெரியும் இல்லையா? All can draw, no? Now you connect it. 1, 2. அவ்வளவுதான் benzene. When you put the central one, if you are drawing, that's all. You try yourself. All of you try, ma. First, you can put benzene. Okay, this is step 1. Blue color. Then okay, and then So better என்ன பண்ணலாம் first star போட்டுங்க, that would be better. Ready? You draw one, all of you try. First draw a star. Okay, complete. Then connect all the stars corners. One, star, and then connect all the stars. One, two, three, 4, 5, 6. So in the pencil ring, you draw a star. Correct? Over. Now you should have the central atom, no? Central one. Now this center, you have to connect all the 6 position. 1, 2, 3, 4, 5, 6. Look here. First connection, second connection, third connection, fourth connection, fifth connection, sixth connection. That's all up to it. Good, right? Now it's okay, no? It's clear, no? It's easy or difficult to draw a structure? Easy only, no? So now if you have 5 means what will be the shape? What will be the shape? So look here. When you have 5, okay, 4 will be in the square, 1 will be in the above, remaining one will be in the lone pairs. So it is octahedral geometry, but leaving your lone pair of electron, it become, what is the shape? Why it's square pyramidal? You have square, and if you are connecting, you will get a pyramid. Am I right? So what is the shape? 5, 1 means A, B, 5 and E. Okay, so A, B, 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 B. So this part become lone pair, B, 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 B. Then what is the shape? So connect. Okay, square pyramidal. If you are getting us, how to draw square pyramidal? Wrong. What you drawn is wrong. Then okay. So for the square, look here. For the square pyramidal, first you draw a square. Look here. You draw a square. Okay. Then put it the center. Then connect the centers. Okay. Then you put above one spot. Now you connect all the 5 places. 1, 2, 3, 4, 5. That's all square pyramid. So what will be there? Another one will become lone pair. That lone pair may be top or bottom, or wherever it will go, but it will be the position. Say, look this structure. When you see that the SF6, if you are having so 2 balls in the, all are 90 degrees, no doubt about it. All are in the 90 degrees. So if you take that BR5F5, bromine in the center, fluorines at the corners. So if you are checking, all will become, but the bond angle get reduced to y mark. Actually, it will be 90 present. Okay. When you XCF4, now check this. 6 lone pair, 6 electron pairs. Among 4 is a bond pair, 2 is the lone pair. The shape will become trigonal, bipyramidal. Sorry, octahedral. In the octahedral, 2 lone pairs are present in the linear manner. The 4 will be in the square. So the molecular geometry is square planar, but the geometry is octahedral. So 4 plus 2. What happened? 4 plus 2. So AB4 and E2. So what will the shape? A, B, 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 B. And then one lone pair in the above and one lone pair in the below. So the shape is square planar and the geometry is octahedral. Okay, is it clear? BSc theory, no doubt, no. So simply you have in mind 2 means linear, 3 means triangular, 4 means next class I will show. Just a minute, I will try. Just if you're looking at PowerPoint, you could easily just a minute, it will sync, huh? It's yeah. See now. So first electron pairs around for writing the Lewis structure, we have to give the electron pair about the central atom. So valence electron of the central atom, 1 electron for each bonding atom, addition or subtraction of electron charge. That divided by 2 gives that value. If you have total electron pairs, 2 means linear, 3 means trigonal planar, 4 means tetragonal, 5 means trigonal bipyramidal, tetragonal or tetrahedral. Why it is tetrahedral? Why not square planar? No. So it has 109°. So 90° means more repulsion. So when the 2 electron pairs are present, in that will be separate as far as possible. That will be most stable. இப்பமே ரெண்டு பக்கத்துல இருக்குன்னா பக்கத்துல இருந்தனா ரொம்ப இறுக்கமா கொஞ்சம் ஸ்ப்ரீ கேஸ் இருக்குன்னா it become more stable. அதனால how many electron pairs இருக்கோ that will be oriented in the space that much better. So if you have that electron pair, it will give the shape like this. Okay. Next, this is Lewis structure. So this is the main point. The repulsion is minimum. It's not showing. Okay, so here, and the repulsion is minimum if electron pairs are oriented as apart as possible. That is the main criteria. Look here, when the two electron pair present means, so this is the central atom. The two, whatever they drawn here, no, this will become equatorial, and this will become axial. It's not connected. Huh? Now, what you can see, those who are in the online, you could see the PowerPoint.
Yes, sir.
Could you hear my voice, ma? So the green color point is very important. Okay. So look here. We have the two pairs, so that will become linear, right? The three electron pair, trigonal, planar, three electron pairs. When you have four, that becomes tetrahedral. So could you see the tetrahedral how the shape will become? 5 means trigonal bipyramidal. 6 means octahedral. This is the basic concept behind the structure. When you go to that, look here. So if any electron pairs, so look here. This will be the equatorial atom and the equatorial plane. The whatever up and down is the axial. Okay, wow. So some of the molecules become T shape, triangular planar, trigonal bipyramidal, square. So these are the experimentally derived shape of the molecule. Okay. So triangular planar. If you take sulfur dioxide, yellow is the sulfur. So yellow in the sulfur, 3 oxygen atom in the red color. When you take the ammonia molecule, nitrogen the blue color, 3 hydrogen atom in the white color. When you take phosphorus pentachloride, phosphorus in the middle, and 3 green will become chlorine atom. So xenon tetrafluoride, if you take, it's a square planar. The 2 lone pair will be above and below. So they are leading the lone pair of electron, they are given the shapes of the molecule. Okay, geometry mean you can include your electron pairs. Okay, next. So when you have only 2 electron pairs, so number of electron pair, spatial representation, bond angle. 2 electron pairs, green is the central. All the keys green is the central. Okay, the red colors are attached atom. It's like AB2 molecule, 180 degree linear. where how it is 180 degree, the distance between the two red color, the angle between the two red color, and 3 means triangular, plane or triangle, 4 means tetrahedron, 109 means 28 minutes. That's what shown in your figure 109.5. And then triangular pyramidal, this will be the shape. Octahedron, this will be the shape. Okay, is it clear? So our balance point theory. What we can do? So theory proposed by Gillespie and Nyman. Okay. So they given that there are 2 electron pairs. First, you have to identify central and peripheral atom. So minimum number of atoms in central atom, maximum number of atoms in peripheral atom. So what is the valence electron of the central atom? You have to identify whether the attached atom is singly bonded or positively charged or negatively charged. That also you have to identify. Then you have to calculate how many number of electron pairs. So 2 pairs of electron will be available. One is bond pair, another one is lone pair. Bond pair means the electrons are in between 2 atoms. Lone pairs are the pair of electron which is occupied by the atom, by the single atom. Between the atom means bond pair. Single atom means lone pair. So when we have the two electron pairs, one will be bond pair, another one will be the lone pair. So lone pair repulsion, magnitude of repulsion is very important. We should not lone pair, bond pair, bond pair, bond pair. So if you have only bond pair, symmetrical structure, whatever we are seeing, 2 electron pair, 3 electron pair, 4 electron pair, that's symmetrical structure. So if you are having lone pair of electron, that symmetry will destroy. So whatever geometry you are expecting, it deviated from the geometry. Actually, if you have taken xenon tetrafluoride, it has totally 6 electron pair, but we have only 4 atom attached. So you are getting square planar. But you are expected it should be a octahedron. So this theory clearly explain why it's so. Then if a compound having triple bond, so it has more repulsion than double bond and single bond. And then if your bond angle decreases due to presence of lone pair, because lone pairs are occupied in the atom, bond pairs are in between the atom. So the lone pair occupied the and the atom means, so the bond angle rate decreases. So if you have only 0 lone pairs, total electron pairs is 2. 0 lone pairs, 3. You have only bond pair, triangle. You have 1 lone pair, then it become bend shape. Then you have 4 tetrahedral, then 1 lone pair, trigonal bipyramidal, and 2 lone pair, right? Okay. And 5 trigonal bipyramidal, only bond pair, 0 lone pair. 1 lone pair means seesaw. Just now we see, no? And then 3 lone pair, T shape. And 2 lone pair, 3 lone pairs means linear. Is it okay? Is it clear? I drawn wrongly, ma. Here. Here. I drawn wrongly. This will not be the shape, you know. The shape will become, this will be wrong. Shape will become B, and 2 lone pairs on this. Okay, then only it become T shape. So if you are drawing the T shape, okay, that's what I also see. It become T shape. Here. Next, see sir, this one become T shape. And you have only 2 electron pairs means 3 lone pairs means it become linear. Okay, why it is T shape? Because due to this lone pair, you have 120-degree deviation. In case if you have the axial means T shape, the explanation for the T shape, A, B, 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 here lone pair, lone pair. Okay. What are the possible structure? And A, B, 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 lone pair. Okay. And then A, B, 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 lone pair and lone pair. So these are the three possible structure. And where are the structure possibility? Any other structure possibility? Where are the possibility? Two axial, one equatorial, two equatorial, one axial, and three axial. If you are looking here, the lone pair have 1, 2, 3, 4, 5, 6. That is 6 90-degree repulsion. What? Lone pair, bond pair repulsion. And 180-degree lone pair repulsion. If you are coming over here, 1, 2, right? 3, 4. So 4 90-degree lone pair, bond pair repulsion, and 120-degree lone pair repulsion. You are coming over here. 1, 1, and then 2, 3. So 3 90-degree lone pair, bond pair repulsion, and 1, 2, 120-degree lone pair, bond pair repulsion, and 1 90-degree lone pair repulsion. Among these three, which is having more lone pair repulsion? Look here, the last one, 90-degree lone pair. Here 120-degree, here 180-degree. So it is rolled up. And then if you are seeing here 180-degree lone pair means it holds good. So we are thinking that it will become triangular. But here you have 6 90-degree repulsion. Where you have, so the minimum magnitude of repulsion minimum in the case of second one. That's why this shape is T shape is possible than in the case of others. Okay, are you able to understand now? So now, if you have 6 means octahedral, 1 means square pyramidal, 2 means square planar, and 3 means T shape. But it is a existing, it's not existing molecule. It is a hypothetical molecule. Okay. So example AX2, AX3, AX4, like that, anion, cations. We will work it out. Later we will work it out, and then we'll go for the. So these are the real examples for water molecule. Water molecules. See tetrahedron how it shape. For the ammonia molecule, how it is shape. What happened? Now, hybridization concept. Okay. So hybridization means what? What is hybridization? Formation. What is hybridization? What is the meaning of two different? What is it? Hope or some other things. What we will call it as hybrid? Mix பண்ணும்போது கிடைக்கிற new one hybrid. Simply I give you an example. You take a red color ink and you are mixing with white coloring or red paint and white paint. You are mixing. What you will get? Red color paint, 10 ml. 10 ml white color paint. You are mixing. What color you will get? What will you do? What color? Pink color. So the pink is not a real color. It's a mixture of red and white. Isn't it? Correct, no? If you are mixing all colors together, then what color you will get? Actually, you will get the black color. So it means it's a hybrid. It's not hybrid. Okay, you are having 10 ml of red ink, 10 ml of white ink, and 10 ml of red paint, 10 ml of white paint. You are mixing together. You are having the quantity 20 ml, but which is different from the red and white. So this is what happens. Okay, then you have, but the property becomes everything will be different. You are taking lambda max, it will have. Okay, then your pink colors, because pink is a hybrid of red and white, so that's why we are saying it's a hybrid. So the process of intermixing of orbital. Likewise, we have many atomic orbital. First of all, the hybridization purely theoretical concept. There is no experimental proof for it. As like your VSC Bethlehem, how they take the electrons. Likewise, the hybridization also, they will not take an account of all those things. They will take only the orbitals. So what they are saying, first they will check with the Berlin code. The valence quantity, what it does, you take the atom, if it is having the unpaired electron, it will combine, it will pair, and it will form a bond. This is what the valence quantity code. But the scientists think that beryllium, just to set the beryllium. What is the electronic configuration for beryllium? 1s2, 2s2. 2s2. So s orbitals are completely filled. As per valence quantity, beryllium do not form the compounds. Then you take boron. What is the electronic configuration? 1s2, 2s2, 2p1. So it has only one unpaired electron. So it will form single bond compound. So boron bonded with some other thing. You take carbon, 1s2, 2s2, 2p2. So two lone unpaired electron. So it will form two bonds as per valence quantity. But we know that carbon has CH4. It will form 4 bonds. How you can say it will form 4 bonds? And boron, we know that boron trifluoride. Boron trifluoride. Beryllium, it has beryllium trifluoride. BeCl. It's naturally existing. Then the Collins they developed the theory. So some of the things are happening in this. So what they come to the conclusion of, they take the beryllium, they written the electronic configuration. You take beryllium. So atomic number is 4, no? 1s2, 2s2. Boron 5, 1s2, 2s2, 2p1. Carbon 6, 1s2, 2s2, 2p2. So when you have the 2s orbital, completely filled. 2p orbital 0, 2s 2p. So sequentially you have SNP orbital, right? 2s2, 2p1, 2s2, 2p2. So then they told, so 2s and 2p orbital having nearly same energy. Nearly same energy. So the electron can be excited very easily from 2s to 2p when the atoms are approached. So what will happen? One of this electron get excited to here. So same way, one of this electron get excited to here. One of this electron get excited to here. Now, if it is excite, what you will get? 2s and 2p for beryllium, boron, and carbon. 2s orbital, 2p orbital. So 2s you have one, 2p you have one. Beryllium 1, 2, 3. 1, 2, 3, 4. Now you check the valency. What is the valency? Here 2, here 3, here 4. So we know that beryllium will form beryllium chloride, boron will form boron trifluoride, carbon will form methane, right? Now the question: what is the shape of s orbital now? What is the shape of p orbital? So, but directionless for s orbital, but the p orbital have px, py, and pz. So it's correct, no? Look here. See the picture. When the S overlapping with S, it will give this bond. Okay, so it will become spherical. When the S can overlap with any other orbital, Px, Py, Pz. So S can overlap with S, it's possible. X can overlap with Px, that is also possible. X can overlap with Py, possible. X can overlap with Pz, possible. Px and Px will overlap. Py and Py will overlap. PZ will overlap, but the PX cannot overlap with the PY, right? PY cannot overlap with PZ. PZ cannot overlap with PX. Why? This is not possible. The overlap are directions. So when you have the s orbital, one more s orbital, it will form a bond like this. When you have p orbital, another p orbital, it will form a bond like this. Or p orbital, it will form bond like this. When the px orbital like this, py orbital like this, means how it will form a bond, isn't it? So here the nodal point is there. Here the electron density is there. Here the electron density is there. How it will form a bond? So there is no possibility. So overlaps are directionless. Okay, direction. It's a vector quantity. That means, okay. Now you tell me, when the s orbital overlap with s orbital, it will give spherical shape. When the p orbital overlap with p orbital, it will give a double shape. And s and p, it will give shapes. For example, when you have the beryllium, 1, 2s orbital, 1, 2p orbital, you take the chlorine atom. Okay, so chlorine means 1s2, 2s2, 2p6, 3s2, 3p5. So you leave this 3s orbital, you have like this, 3p orbital, 1, 2, 3, 4, 5. One electron only add. So you have like pz orbital is there. Okay, now the p orbital going to overlap with s orbital, p orbital going to overlap with p orbital. Up you are expecting two different shapes, right? But when you are experimentally seeing beryllium trichloride is a linear shape with a bond angle of 180 degree. How it is possible? And the SS overlap means it will be one shape. PP overlap means you will get one shape. So one chlorine have one property, another chlorine have another property, bond length and bond. But the bond length and bond distance or bond angles are same. Then they come to the conclusion that so the 2s and 2p orbitals so approximately are equal energy orbital will undergo hybridization. It will form a new set of orbitals which are equal in energy, equal in shape. Everything will become same. It differs from the s and p orbital. So that orbital is known as sp hybrid orbital. If you are having 1s orbital, 1p orbital, sp. 1s and 2p, sp2. 1s and 3p, sp3. 1s and 4p, sp4r. Because you have only 3 p orbitals. So next sp3 d2, sp3 d4, like that it will go. Okay, so it's same like you are having red color, white color, you are mixing, you are getting 20 ml, but the 20 ml are different from your red and white. This is called hybridization. Is it clear? Are you able to understand? Now we'll go now. So no need of explanation, right? So this is how the hybridization concept are done. For example, when you are doing molecular orbital theory, or you are taking a very big molecule, for the molecular orbital theory become very, very difficult. Like by using this hybridization, you can explain all those things, all the bonding parameters, everything you can explain using the hybridization. So now we'll go for this. So hybridization means s orbital, p orbital, d orbital, f orbital. What are the conditions for hybridization? So when you are having organic molecules, that organic molecules you have three hybridization marks: sp, sp2, and sp3. Okay, one s orbital, one p orbital, you give two sp orbital. One s orbital, two p orbital, sp2. Three sp2. 1 plus 2, how much? 3. So 1 s orbital, 3 p orbital, 1 plus 3, 4, 4 sp3 orbital. So the carbon atomic number 4, valence is 4. To account the valency, so what happened? 1s2, 2s2, 2p2 is there. So one of this electron get over up to this one. Correct? From here to here. 2s2, 2pz. So in the excited state, we have 1, 2, 3, 4, 4 unpaired electron. So the valence will become 4. Okay. So what are the feature of hybrid orbital? Number of hybrid orbital formed equal to number of atomic orbitals. The type of hybrid orbital formed vary with the type of atomic orbital. S or P or D orbital. And also very, very important point, the hybridization will go for the single atom. When you take a methane molecule, what is the central atom? That atom will undergo hybridization. When you take an ethane molecule, CH3 means this carbon and this carbon only will undergo hybridization, not the hydrogen. Okay, the hybrid it will undergo hybridization, it will form a molecule, sorry, it will form a hybrid orbital, then only overlap will occur. Okay, so it will undergo off field also, will undergo completely field also will undergo. இது எல்லாமே எதை பொறுத்திருக்குன்னா based on the overlap. So first sp3 hybridization. The ground state, the carbon has 2s2 2p2. The excited state it has 2s2 2p2. Correct? So what happened? It differs from 2s and 2p orbital. The 4 orbitals will form, no, they are equal in energy. That's why 4 sp3 orbitals are 1, 2, 3, 4. Now the atoms coming. What? 4 hydrogen atom coming. 4 hydrogen atom will overlap with the 4 sp3 hybrid orbital. So if the bonding occur in the bond axis means in the nucleus, on the nucleus would axis the bond axis. So இது ஒரு atom இருக்கு, இந்த ஒரு atom இருக்கு, இது ரெண்டும் bond ஆகுதுன்னா this is called bond axis. So bond axis ல bond form பண்ணுச்சுன்னா that is form sigma bond. Perpendicular bond axis எதுவோ அதுக்கு perpendicular overlap இருக்குன்னா அது pi. So if you are having sp3 hybrid orbital means sp3 hybrid orbital will give tetrahedral shape. Tetrahedral 1, 2, 3, 4. You know that what is the tetrahedral shape? 2 in the same plane, one will be the towards you, another one will be the back side of you. So in the same side, the s orbital overlap means this will be the bond axis. So sigma bond. This will be the bond axis, sigma bond. This will be the bond axis, sigma bond. This will be the bond axis, sigma bond. So that it will form 4 sigma bond. That's what they mentioned in the figures. Right? 2 dot, 2 dot, 2 dot, 2 dot. One from the sp3, whatever that gray color. You have the blue color is the hydrogen atom. It's going to overlap with the same axis of your sp3. So that's why sigma bond. Another sigma bond. Another sigma bond. Is it clear? So look here. One s orbital, 3p orbital, we do sp3 hybrid orbital, right? So it's sp3 1, 2, 3, 4. Okay. So this will be the bond axis. This is along the 4 bond axis forming a bonds. you are seeing, this is how the tetrahedral molecules are formed. So with the 2 orbital it will form sp3. One oriented in this direction, another in this direction, third one, four part of the tetrahedron. So this is the four. Now the four hydrogen 1, 2, 3, 4, 5. Okay, is it clear? So this is called sp3 hybridization. So now another example. When you have ethane molecule means C2H6. If the hydrocarbon lessons are coming means there we have this. Okay. So simply now you understand first organic, then you go for the inorganic. It becomes very easy. Now the two carbon. For organic molecule, there is simple one. How you can say you take a carbon atom. How much atom was attached to that? You take this carbon atom. How many atoms attached? So 4 atoms. 4 atoms. What is hybridization? Very good. sp3 hybridization. So it will give the tetrahedron. So that's why 1, 2, 3, 4. Take this carbon. How many atoms attached? 1, 2, 3, 4 carbon. So 4 atom plus 4 atom, right? So it will be sp3. This is also under the sp3 hybridization. So one of the sp3 hybrid orbital of this carbon overlap with another sp3 hybrid orbital of this carbon. It will form this. Remaining 3 hydrogen atom it will form like this. So when you are seeing the molecule, it will become like this. So sp3, sp3, 1 sigma bond, sp3s, another sigma bond, third, fourth, fifth, sixth, 7. So totally it will form 7 sigma bond. Among the 7 sigma bond, 6 are carbon hydrogen sigma bond. 1 is carbon carbon sigma bond. So this is different from these 3. Am I right? Okay. So this will be that it has a 4 bond, 190 or 109.5. Tetrahedral. When you are having a bond angle, it becomes 1.09 Armstrong. Bond energy becomes like this. So when you have the ethane molecule, 7 sigma bond, 6 carbon hydrogen, 1 carbon carbon. This will be the bond angle. It will not change. Tetrahedral. One tetrahedron, another tetrahedron joined. Okay. So it will join. So this tetrahedron joined with another tetrahedron. Okay. And then you go to the trigonal hybridization. sp2 hybridization. sp2 hybridization means same way carbon will 2s to 2p2. One of the electron get excited, so you have 1s orbital and 3p orbital. But in the sp2 hybridization, 3 only needed. So what will happen? It will take only 3. So 1 and 2 and 3. These 3s are missing, so it will give 3. 1 will become unhybridized p orbital. Clear? So 1s orbital and 2p orbital missing. It gives 3. The 3 will be oriented in 120 direction. Okay, 1 is there, no, that become above and below of the plane. If you are having pen like this, so 3 will form a triangle. 1 unhybridized p orbital, you know, that will be perpendicular. Okay, so this sp2, sp2, sp2. Suppose one more carbon also sp2, ethylene molecule CH2 double bond CH2. That carbon attached 2 hydrogen, 1 carbon. So it needs 3. sp2, sp2, sp2. Okay. So you have 1 unhybridized p orbital. One more sp2. So sp2, sp2 overlap this way. sp2s, 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 sp2s. Now you have 2 p orbital. Look here. Now 1 sp2, sp2 overlap. 1 sp2s, 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 sp2s. Now we have 2 sp, 2 p orbital. 2 unhybridized p orbitals. Okay, so it sideways it overlap. Please remember, I told you when the overlap occur in the bond axis, it will form a sigma bond. If it is perpendicular to the bond axis, illa triangles irukku. Okay, va p orbital perpendicular ah irukku. Indoor p orbital perpendicular ah irukku. இந்த மூணுத்துக்குமே perpendicular தான இருக்கு. So it is very much perpendicular to all the bond axes. So it will form a pi bond. Undivided p orbital because look here, you have one atom. One undivided p orbital is there. No, one electron is there. So in the ethylene molecule, you have one electron and one electron. It will overlap above and below. So how it will become? We have the bread jump over above and jump below. It will become like that. Or like sandwich. So stuff will be in the middle. Two bread will be in the top and bottom. No, that pi bonds will become like that. That stuff is known as sigma bonds. So in the ethylene molecule, CH2 double bond CH2. No, so the carbon is attached to two hydrogen and one carbon. That's why it undergoes sp2 hybridization. So each carbon having unhybrid sp orbital. So hybrid orbital and atomic orbital form sigma bond, but it will not form pi bond. Hybrid orbital will not form a pi bond. Hybrid orbital always form a sigma bond. This is the hint we are getting. Okay. So unhybrid sp orbital forming a pi bond. So this will become 120. If you are calculating, this is also 120. So now you have 1, 2, 3, 4, 5. 5 sigma bonds. Among the 5 sigma bond, 1 carbon-carbon, 4 carbon hydrogen. Okay. And then we have 1 carbon-carbon, 5 bonds. So look here. This is the geometry of ethylene molecule. So carbon-carbon, 2p orbital. The 2p orbitals above and below, it will form a pi bond. So if you are looking, the bond become like this. All the sigma bonds are indicated in the blue. The yellow color indicates the pi bonds. So this is the molecules. This will be the. Is it clear? This picture clear? No? Shall we go? So sp2 hybridization totally what we are getting. We have 5, 4, and 1, and 1 carbon. So 120 angle triangular planar. The carbon hydrogen bond angle is 109. This will become 1.34 because of carbon-carbon double bond. When the carbon-carbon double bond increases, means the distance decreases. Bond order increases, bond distance decreases. That's what it shows. So look here, when it's single bond, when it's single bond, it becomes 1.54. 1.54, right? So carbon-carbon single bond. When you are coming to the carbon-carbon double bond, what is the bond angle? 1.34 angstrom, right? Then sp hybridization. sp hybridization means you tell me what will happen. The carbon which will attach two atoms, then only it will undergo sp hybridization. So you need only 2. So 2 sp hybridization remain to the unhybridized. So look here, this will take these 2. It will give sp hybridization. Remaining will be the which is perpendicular to this axis. Okay. So this is how it will form. Correct. Correct. This will be the atomic orbital. This is atomic orbital. This is hybrid orbital. So when you are mixing yellow and green color, you will get a blue color like this. For understanding purpose only, you have to choose this picture. Okay. Likewise, it will be like this. So now, self-understanding. You explain it, Mark, how it is. Two of you explain it. Really answer by the way. I will understand or not? Then you tell me. Just it should be interactive. Now, whether you understand or not, I can understand. Okay. Otherwise, it become very difficult task. You know. You tell me how it is. You take acetylene molecule CH triple bond CH. Okay. So the carbon atom which is attached to one carbon and one hydrogen. It requires 2 hybrid orbitals. That's why we take 2s and 2p. Leaving 2p orbitals or 2 2p orbitals. So now 2sp will forming a bond. It gives 1 sigma bond. It gives another sigma bond, another sigma bond. So 3 sigma bond. Now you have 2p y orbital over. See, look here. You have one electron, no? 2 unhybrid sp orbital, no? 2 electrons. rules there, no? That's why. So in this picture, it's clearly shown that 2py and 2pz, 2p overlapping will form back side of your pipe bonds. 2pz, so y will form above and below. Z will form front and back. So in middle we have this. So the pipe bonds are in circle manner. So here this is the SP address. So you are taking beryllium chloride. This is the case. Beryllium chloride, you have the case, but the only difference, beryllium do not have pipe bonds. You will get a linear shape. Whereas ethylene, acetylene, it has the pipe bond above, below, front, back. Okay. So now it becomes the triple bond, no? The bond angle. You see, bond angle, bond length 1.20, 1.54, 1.34, 1.20. When the bond order increases, bond length decreases. Then bond energy get increases. Okay, is it clear? Pencil வேண்டாம். நம்ம வந்து simple போலாம். இப்போ types of overlap are. When the s orbital overlap s orbital, it gives excess overlap. P orbital can overlap like this, and s and p overlap like this. P overlap, it means it will form a pipe bond. Same axis. Form a pipe bond. Now we will go to that inorganic hybridization. So to look this, what you can understand from this picture? What is this? Those who are in the online, please answer it. What is this blue color? What is the blue color? What is the red color? Huh? What is the pink color? Huh? Very good. So, mule is neither ours nor a dog. Then what is this? Okay, this can be explained in the resonance factor. Okay, that time I will tell you. Just a minute. Sterilization. இதுதான் இப்ப பார்த்தோம் இல்லையா? So to find out the hybridization, this is the rule. For any molecule, you have to identify the central and peripheral atom. Then the valence electron of both the atom you have to add it. Okay, then it should be divided by 8. Why it is 8? Oh, that's why you are divided by 8. And then the quotient will give the sigma bond, and the remainder will give the number of non-bonded atom. Okay, shall we try for it? For example, you try for SF6. We'll do one by one. So what molecule we can do? You tell me any other molecule. NH3 shall we do? Huh? NH3. So what is the valence electron on nitrogen? 5. Then So when you have hydrogen, that you have to divide it by 2. Okay, that is the main problem. So hydrogen means 3 into 1. Okay, so hydrogens are exception, you have to divide by 2. Sorry. So 8 by 2, how much? So 4 means sp3 hybridization. So the next step, PCl5. Phosphorus is 5 and 5 into 7 chlorine atoms. 7, okay, divided by 8. 5 plus 5 sevens are 35. 35, that divided by 8. 40 by 8, how much? Then what is the hybridization? sp3. Look here. NCl3, nitrogen 5, chlorine atom 7. 3 sevens are 21. 21 plus 5, 26. 26 if you are dividing by 8. 3 8s are 24. Remainder you have 2. So the 2 by 2 will give 1. 3. So the quotient give the sigma bond and the remainder give the non-bond. So nitrogen have 1 lone pair and 3 bond pair. So in the tetrahedron you have no NCl3 and then the hybridization become sp3 plus because 3 plus 1. 4. That bond angle is less than 109. Okay, because of lone pair of electron. And then BCl3, boron is 3, chlorine is 7. 3 sevens are 21. 21 plus 3, 24. 24 by 8, 3. So no one. Only 3 means the hybridization is sp2, right? So it become triangulation. You calculate for XeF2O2. Xenon is 8. Fluorine is 7. Oxygen is 6. Calculate. What do you get? Time upon. Next class என்ன உங்களுக்கு? Next week இன்னும் இன்னும் 2 கிளாஸ்ல ஒரு நாள் வேலன்ஸ் பாண்ட் தியரி, ஒரு நாள் மாலிகுலர் தியரி. இது ஓகேவா உங்களுக்கு? சரி, இன்ட்ரஸ்டிங்கா இருக்கா? Anything you want more? Yes. இன்னும் ஃபாஸ்டா போகணும், சரியா? நிறைய பேர் இல்ல, அதனால கொஞ்சம் ஸ்லோலி. Now I will tell you to find out the method very simply for checking up. And then if you are going for any competitive exam or one word like that means simply XeF2O2. So which is the central atom? Xenons. 1, 2, 3, 4, 5, 6, 7, 8. Right? So the fluorine will form a single bond. Fluorine will form a single bond. Then oxygen will form a double bond. Right? Oxygen will form a double bond. Am I correct? And then 1. So totally 1, 2, 3, 4. 4 bond pair plus 1 lone pair. So total how much? 5. 5 means what is hybridization? sp3 D. Because 1s, 3p, 1d, 5. So this is what you find out now. All valence electron you are adding, no? There you remember all the valence electron. Here, simply you can put it. You take any molecule, some other molecule, tell me. See, we are talking about only the ionic molecule. We are not talking about covalent molecule. For the covalent molecule, we cannot draw this. And then You have to take a simple inorganic model. Isn't a copper is a D block element, no? Al. So aluminium means 1, 2, 3. Am I right? What is the valence electron for aluminum? Boron, aluminum, gallium, diphthalate. So 3. 1 chlorine atom, second chlorine atom, third chlorine atom. Then 3 bond pairs, right? Then what is that? sp2 hybridization. Correct? Huh? Now you coming to that AlCl3, aluminum is 7. Sorry, aluminum is 3. 3 into 7 into 3, that divided by 8. 3 plus 3 sevens are 21. 21 by 8. 24 by 8. What you will get? 3, no? Correct? Easy? Any molecule you can put. You try yourself. Okay. Yes. Is any molecule you want? Those who are in the online? Nobody is talking. So now you can do NO2 minus for the ionic molecules. Both method for our method and then NO2 minus. Nitrogen is the atom, no? 1, 2, 3, 4, 5. Oxygen will form double bond 1. And then 1 minus charge is there. So you have to add 1 X extra. So, and then second nitrogen will form this. The third will form this. So 2 bond pair plus 1 lone pair. 3. 3 means sp2, right? Now we'll check. You tell me nitrogen is 5 plus 2 into 6 plus 1, that divided by 8. So 2 6 are 12. 12 plus 1, 13. 13 plus 1, 18. 18 by 8. So what you will get? 2 8s are 16. Remainder 2. 2 divided by 2, 1. So 2 plus 1, it gives sigma bond. This is non-bond. Then 3. Then what is the hybridization? sp2. Both are same, no? Which is very easy. This method very easy, no? You can try for CO3 2 minus. Come and do here. Come and do here. For do CO3 2 minus. 1 by 1. Huh? I will give the next molecule to you. 4 and 2 minus. Oh, CO3
2 minus.
okay. Okay, now you put it carbon. Carbon is 4 plus 3 into
6.
6 plus 2, 8. 24. 24 by 8. 3. So sp2, right? You do this molecule. You tell me, ma, which molecule you will give. No. That will become simple, no? HCO3. Simple molecule. 1, 2, 3, 4, 5, 6, 3. So oxygen.
Triple bond or double bond? Triple bond or double bond?
நீங்க சொல்லணும்.
Confuses.
Double bond.
So now SP3s.
But if you are drawing geometry, what you will get? Now you connect 3 in there. So 3 plus 1, 4, SP3. But what geometry you will get? What shape you will get?
4 and
You have one load back. 3 1 plus 1 load back. No. Here. Correct. So this is how you will work it out. Okay. Next class we'll see that today how much we completed. Next development theory. So hybridization we have completed some more now. We will do some other molecule and then we directly go to the next one. Okay. Yes. Next class we will complete Monday. Okay. So is it okay in today class? Are you happy with this today class? Any other suggestion? We'll go like this now.